Good morning, all of you. Good morning. Am I audible to you? Okay, shall we start? Okay, so in this particular lecture, we will be keep silence because recording is going on and it will be made available to you. So we don't want any disturbance. Okay, so in this particular lecture, we will see random forest method. Okay, and it is one of the machine learning algorithm used for classification purposes. So before we start the random forest, first of all, we need to understand some basic terminologies, especially ensemble learning. So we know that when we talk about learning means we receive information and we will try to extract some information. So this is how we learn. So one of the important approach is ensemble learning. And if you understand the fundamental of ensemble learning, I'm very sure that you will easily understand the concept of random forest. Okay, so in order to understand the concept of ensemble learning, we will try to understand the concept with the help of example. So when you go for buying a car, so generally what you do, you can have many options. For example, you can directly go to a shop and you can ask to the owner which are the different cars available with you, and you will check all the models, their configurations, and that owner will tell you out of these 4 5 car models, this is the best model and you can buy. So this is one option you can go ahead with. But is it the good option? Many times no. So what you may do, you can go ahead with online platform where you will check different models manufactured by different companies. You will compare those models for technical configuration. Along with that, you will also check the review comments given by the reviewers. So this is another approach where you will get a lot of information from the existing customers on various websites. This is another approach in order to decide which is the most suitable model for your budget, for your requirements. Along with that, you can go ahead with asking a questions to your friends who are already using such kind of cars. So your friends, your colleagues may give some important information, and based on that information, you can also make a decision. So what I'm trying to tell you in with this example, just buying a single car, you will do a lot of research. You get information from the seller, you get information from online websites, you get information from your friends and colleagues. So different sources will be there for data collection. That information you will analyze. Based on that analysis, you will also check what is the your budget. Then based on your budget, you also, please come in. Based on your budget and your requirement, you finally select the car for the your case, right? So what we did here, we learned from different customers, so that learning is there. And the people or the sources from you learned, that is a diverse. And this particular approach is called as ensemble learning. So our ultimate goal is to learn, but the learning should happen from different sources. You should not rely on a single source. Is it fine? So this is a particular example of ensemble learning. We will take one more example. Suppose you prepared a movie, short movie, and before you release that movie into the theaters or some other platform, you want to know the quality of the movie. So, what options do you have? First of all, you can think of asking your best friend, and you will ask, watch this particular movie and tell me whether it is a good or bad. But if you rely only on a single person who is your best friend, then what may happen? He is your best friend and he know that you put a lot of effort in the preparation of the movie. So he may be biased. He will say you prepared a very good movie. And why he's saying? Because he know you put a lot of time on that movie. So that biasness will create a problem and he may not give a good feedback. But of course, he will tell you something about the movie. Second option could be you can ask your five friends or five colleagues or five experts about the quality of the movie. And the five people will give their opinion about the quality of the movie. Now, when you compare the feedback given by five people with the feedback received by a single person, which is the best option? Of course, five persons, right? But in this case, what may be the problem? They may not be expert in movie. They may be some of them may be interested in action movies. Some of them may be interested in comedy movies. So, according to their understanding, they will give their opinion. So if we compare these two options, asking a single person and asking five people, definitely five people will give better feedback. But that may not be the best outcome. So what you may do, you can ask 50 students or 50 people to give their feedback. So what will happen? These 50 colleagues or friends may be your best friend. Some of may be unknown to you. Some of are expert in the movie. So a diverse information you will receive. And based on the aggregating result, you can conclude that the movie is very poor or average or very good. So similar conclusion you can draw. So this is another example where what we have seen once again, you will collect information from diverse group of people. From that information you learn something by processing that information, and finally you make some conclusion. So this particular approach is called as ensemble learning. Any question related to ensemble learning? Okay. So the formal definition of ensemble learning is ensemble is a machine learning concept in which multiple models are trained using the same learning algorithm. So you are collecting the information from different set of people. For each set of people, you will receive some information. So whatever information processing will be there, that will be individual model. For example, there are four rows. So whatever information received by first row, I will develop first model. This is second row. Whatever information will be collected, second model. Similarly with the third and fourth row. So each model will be different because information received by each and every individual is different. That will be a machine learning model, and based on that, I will make a conclusion. For example, okay, we will take that example later. Okay. Now, when we talk about ensemble learning, again there are two subtypes of ensemble learning. First one is bagging, and second one is boosting. Now, just read the definition of the bagging and boosting. So, from the definition, some of you may understand the meaning of boosting and bagging. Some of you may say, sir, it's very difficult to understand. Right. Now, in order to understand the concept of bagging and boosting, we will take examples. Okay. And then we will try to understand. But one important thing I would like to highlight here, out of boosting and bagging in our syllabus we will be focusing more on bagging, because in bagging one of the example is random forest. Is it clear? So yes, so suppose you have a population. Can you see this image? Yes. So look at that image carefully. So you have a population, for example all students from the given class. So from a given class of 70-80 student, I will be drawing certain samples. So this is sample number 1, sample number 2, and sample number 3, let's say. So for example, from your class, this particular row is first sample, this is second sample, and third row is third sample. That could be an option to draw a sample. Or what I will do, the all the students from first row and some of the students from second row could be my first sample. So it will be your decision how you will go ahead with the sample preparation. So what you can see, from the population you are drawing 3 samples. Now for each sample you will be developing machine learning algorithm. So you can see here these are the 3 models. So my question is, do you think all the 3 models will be same? Maybe same, but most of the time there will be a difference between these 3 models, because in each sample different students are there. They have their own thought processes. Now, once you prepare this particular model for each sample, in this case, 3 models are there for 3 samples. Now, model first will say something, model second will say something, model third will say something. So you will check where is the majority, and majority will be the final conclusion. Are you getting my point? There will be a population. From that population, we can draw samples. So here we have drawn 3 samples. For each sample, we prepared model. Each model will give some output, and the majority will be the winner. So that will be the final conclusion. So this is how the bagging model works. Any question related to bagging model? Okay, if you want to ask something, you can ask. Otherwise, don't speak with your friends. Okay, you may disturb the class. Now, the boosting method will work in a different way. So from figure itself, you will understand something about the boosting technique and the difference between the bagging and boosting. So what we do, again in boosting also there is a population. Student in the class will be the population. You are drawing 3 samples, sample 1, sample 2 and sample 3. But there is a slight change while preparation of the model. So for first sample, you will develop the model. Now, once the first model will be ready, we will use that model and the data along with the second sample that you combine, and based on that you will prepare a second model. I will repeat once again. For sample number 1, you will develop a model. You will test that model for its accuracy. Then you will combine that first model with the second sample, and based on the combination or combinedly you will develop a second model. Again you go ahead, you will take the second model and the information, you will combine it with the third sample, and based on that combination you will prepare the third sample. Now question comes, do you think the accuracy of model 1, model 2 and model 3 will be same? No. Now logically tell me, accuracy of which model may be better? Probability third one. Now model 1 will say some kind of output, model 2 will say something output, and model 3 will also tell you some output. Again here we will go with the majority. Majority will be the final output, right? So any question related to bagging and boosting? Any question? Just conceptual point of view, yes. Majority. Okay, we will take some particular example so that you will come to know in upcoming slides. So basic thought process is clear. So we discuss ensemble learning. In ensemble learning there are 2 types, bagging and boosting. We try to understand the difference between bagging and boosting, right? Now we will go with the typical examples so that you will come to know. Okay, suppose T students are there. So TA, TB, TC, 3 divisions are there, right? Now when we club all the students together, it will become a population. So let's say the population is students of all T divisions. That will be our population. Now from that population we can draw samples. For example, TA students first sample, TB second sample, TC third sample. So we have now three samples. Now for TA division we developed model A. For B students we develop model B, and similarly for C division we develop model C. Now model A is developed for by using decision tree. Model B is developed by using support vector machine algorithm, and model C is developed by using Navy based algorithm. Now question is how I am teaching to T students. So that is our objective. We want to know that how I am teaching to the students, and that feedback we received from TA, TB and TC. So from the feedback we develop these three models. Okay. So do you really think the feedback received by TA and TB will be must be same? No, there will be difference. What about TC? May be different, right? So we received the feedback from all the three divisions. We developed models by using different methods. Now the TA division said, "I'm a good teacher." Okay, I may not be. TB division said, "I'm not a good teacher." Yes. And from TC division say again, "I'm a good teacher." So we have three samples, we have three models, and each model provided you some outcomes, and this is the outcome. Now what you need to do, you need to count how many samples are saying that I am a good teacher, and how many samples are saying I am a bad teacher, right? And based on the majority we will draw the conclusion. So in this example, TA and TC students are saying I am a good teacher, and we are saying I am a not good teacher. So what will be the conclusion? I am taking undue advantage, right? So we can say that I am a good teacher. So is it clear from this example the concept of bagging? Any question? Do you understand how bagging technique works? Okay. Now we will go ahead, and now we will try to connect it with the random forest. In the definition of random forest, what we have seen, sorry, bagging definition, what we have seen, random forest is an example of bagging method. So we can say that there is a lot of similarity between bagging method and random forest method. And we will try to understand only two major difference between bagging and uh, random forest method. Okay. So a lot of write-up will be there. Later you can read it. I will just try to focus on the two differences through which you will clearly understand what is the difference between bagging method and random forest method. So first difference is related to this highlighted part. Can you see? In contrary, random forest models decide where to split based on a random selection of features. Okay, so we will just read that particular statement, and we will try to understand what is bagging and how is random forest. So for example, for TA division, how many courses are there? Approximately five. So five courses are there, right? So five courses means five teachers will be there, right? So feedback of teacher A, feedback of teacher B, C, D and E. So these are the five feedbacks based for each courses. Now again there are 80 students. So five teachers, 80 student, and we are talking about samples. So first row, first sample, second row, second sample, third row, third sample, and fourth row, fourth sample. Right. So whatever feedbacks we are receiving for five teachers, these are the features. Now I asked row number one that you will be giving feedback to only Rajkumar Patil sir. I told row 2 to give feedback only for Momin sir. For third row, third faculty, and fourth row, fourth faculty. So what we are doing, we are telling a group of students to give feedback for only one teacher, even though they are studying all the five courses, right? So I am making a particular decision, one row, one student. Do you think this is a really good approach? No. But if I ask you that all students will give feedback for all faculty members, will it be a good option? Yes. So the decision making. So this is a very simple example where you can easily say that, sir, we will give feedback for all faculty member, and that is the correct option. But in practical application, it may be difficult. The problem may not be clear to you. So the bagging technique, what it does, it creates a sample, and each sample will talk about a group of features. So for example, this row talks about only 4 features, this row will talk about 10 features, third row will talk about 15 feature. So such type of assumption will be there in the bagging technique, and that is again random. Now whereas in case of random forest, a logic is applied, how the features will be segregated. So that is a very critical part, and based on that, decision will be made. So this is the first method, where random forest method decides how to split the data before developing machine learning algorithm. Whereas bagging method randomly distribute the features to each sample and develops the model. So this is the first difference. Now second difference is, let's let us look at this particular example. This is same example if we compare with the previous example, right? But do you see any difference between the last slide example and this particular slide example? Any difference do you see? Same model, right? So in previous example where we talked about which method, bagging, where we talked about model A, model B, and model C, and these three models are developed by using different algorithms. Whereas in case of random forest, for all the models we are applying decision tree only. Did you understand the difference? So when we talk about random forest, we always use decision tree. But in case of bagging technique, we may go for different algorithms. So these are the two major difference. Along with that, there are so many other differentiating points, but this is for understanding purpose. Now question comes, how will you memorize random forest? So when we say a word forest, so what will you see in the forest? General word forest, number of trees, right? More number of trees means dense forest, less number of trees in the forest means काय म्हणतो, लेस नंबर ऑफ ट्रीज, काय असतो वर्ड त्याला, डेन्स. डेन्सच्या अपोजिट कुठला वर्ड असतो? Okay, think on it. But try to connect. Forest means decision tree. Tree means decision tree. In that tree word is there. Forest, there are trees. So whenever you say decision tree, you can connect with random forest. When a question will be related to random forest, always think that you have to go ahead with decision tree algorithms. So random forest method always use decision tree algorithms, and for each and every sample decision tree will be there. If number of trees are there, more number of trees are there, dense forest will be there, accuracy of the model will be higher. If less number of trees will be there, less number of decision trees will be there. Less number of decision trees, the quality of the model will be at lower end, or the efficiency will be at lower end. So your role will be drawing as many samples from the population. For each sample you need to develop decision tree. Each decision tree will tell the efficiency of the model, and based on the voting you can make the final decision. Again, we will try to link with the machine learning algorithms. So random forest is a supervised machine learning algorithm. So supervised machine learning algorithm means label the data. Always remember, again and again I will tell you. Again, random forest can be used for classification purpose as well as regression purpose. Classification, last time we saw, the this particular class can be classified based on gender, male, female. So this is a typical example of classification. In case of regression, what will be the population of India in 2015? That is a prediction. So regression model will come into the picture. So random forest can be used for both the cases. However, this particular algorithm is more popularly used for classification purpose. Again, as I already mentioned, more decision trees, efficiency of the model will be better. Less number of trees, decision will be with less efficiency. Again, we will take another simple example. Suppose this is a forest and we have to decide whether apple trees are more or mango trees are more in that forest. Very simple example. Okay, so what we can do, we can take a first sample. Please look at the highlighted part. Okay, so for that sample we develop a decision tree, and that decision tree said that there are more number of apple trees, for example. Then I took a second sample, developed second decision tree, and that decision tree is saying that mango trees are more in the forest. Then I went to the third sample, develop a decision tree, and that is saying that there are more apple trees. So you have three samples, three models. Majority will be apple. So what will be your conclusion? In that particular forest, apple trees are more. Yes, simple. But we will look at this example in a different way. How you have to look at, the forest is very large. It covers a lot of area. Now you can see the area related to sample 1, sample 2 and sample 3. So if you compare the size of the forest, these areas are very small, right? So whatever three samples we have drawn, their final decision may be wrong. I'm not saying it is completely wrong. It may be wrong. So in order to increase the accuracy, what you will do? You will go on increasing the number of samples. So first, second, third, fourth, fifth, let's say sixth, seventh. Now, what you are observing, as we go on increasing the number of samples, it is covering major portion of the forest. Yes or no? And when your number of samples covering more area or region of the forest, what will be the outcome? More accurate outcome will be there. So the final decision will be very close to the reality. So what conclusion we can draw from this example? It is always good to draw as many samples as possible in order to predict the final outcome in a better accuracy. Is it clear? Okay. Any doubt related to random forest? Any doubt related to bagging, ensemble learning? Okay. Now again same example will take with the in the terms of algorithm. Generally we are in the lab session we tell you write the algorithm and then write the Python code, right? So step number 1, first start with the selection of random samples from the given data set. So data set is T students. So first step in the algorithm will be drawing the sample. Second step, this algorithm will construct a decision tree for every sample. So we have three samples. For each sample, you need to develop the model by using decision tree. So converting the sample into decision tree. Next step, the question is how I am teaching to your class, and these are the outcomes. So step number 3, you need to collect the output for each sample and go for the voting. How many groups are, how many samples saying I'm a good teacher, and how many samples are saying I'm not a good teacher. And then based on the majority, you have to make the final conclusion. So basically the random forest, if somebody asked you, write down the algorithm for the random forest, then these 4 steps we are expecting. You can also again subdivide into small steps, and you can write, there is a flexibility, but write down the steps and give one simple example, and you will get good marks. Okay, and this understanding is also very essential when you are dealing with a huge data set. Is it fine? Now, okay, now this particular part is related to advantages, disadvantages, similarity. So one by one, you will quickly read it. Okay, we will start from you and read it loudly. Only one statement. Okay, and we will go with the sequence. Yes, please speak loudly so that the corner student can listen. I will ask you what he is reading. Ah, yes, you can remove your mask and you can. No issue.
Diversity attribute variables which are considered within the mapping and individual. This is newspaper.
Okay, anybody would like to say what is the meaning of that statement? In the previous example, what we have seen, there is a huge forest. First sample was saying apple tree, second sample was saying mango tree, third was saying something. Suppose in that forest 10 different types of trees are there. Then do you really think a given sample will consist of all 10 types of trees? No. Practically, it's very difficult to have it. So that is the meaning of first statement. So it will be a diverse. Again, each and every sample, it is a diverse. So if this is a forest, you can draw first sample from here, second sample from here, third sample from here, fourth one can be a combination of these two, next one will be a combination of these two. So diversity will be always there. Okay, second statement, please start reading from since.
Since each tree, since each tree does not consider all the feature space is reduced.
Feature space is reduced. So in each sample, all features will not be there. So along with the diversity, feature space will be reduced. So out of 10, suppose in a one sample only one feature is there. So feature space will get reduced. Next.
Each tree is created independently out of different data and attributes. This means that we can make full use of the CPU to build random forests.
Okay, so suppose you are dealing with the terabyte data. Then it's a big question that how will you draw a sample? Then you will check what is the capacity of my laptop, and based on that I will pick the samples and I can go ahead with the analysis, so that there is a complete usage of the CPU, right? But along with that, what else we can do? You can develop decision tree for each and every sample independently. So for first sample, your decision tree will be different. For second sample, your decision tree will be different. कारण प्रत्येक ट्री मध्ये सेम सॅम्पल आहेत का, सगळे फीचर्स आहेत का, नाही आहेत. नेक्स्ट.
In a random forest, we don't have to segregate the data for a train and test as there is always be 50% of the data which is not seen by the decision.
Okay, so here very interesting thing is that suppose 100 students are in your class. So what I will do, I will randomly pick 70 students, and I will take the feedback how I am teaching to your class. So this is sample number 1. Next time what I will do, I will take next 70 students. Okay, so this is sample number 2, and I'm asking how I'm teaching to your class. So every time out of 100 students, I am picking 30 students. So for training the model, so 30 students are in the reserve. Next time in the class of 100 students, I am picking next 70 students. Some of the students may be common in sample number 1 and sample number 2, but there is a case of 30 students will not be there in the sample. So that we are assuring. Okay, and this is very important. Whenever you are dealing with the data, you need to divide the data into two groups. First, training data set and testing data set. So out of 100, 70 students we will take the for the training, and we will develop the model, and remaining 30 students will be there for the testing. So how this will work? I will ask, I will take the feedback from the 70 students. I will ask how I am teaching to your class. So you said not a good teacher. Then randomly from the remaining 30 students, I will take one by one and I will ask how I am teaching. So the 70 student or the training model is saying I am not a good teacher, and the unknown student, that is the testing student, saying I am a good teacher. Second student may say I am a good teacher. So we are just connecting whether the training model is working properly for the testing or not. So 70 for training, remaining 30 for testing. Next. Yes, next.
Stability arises because the result is based on majority voting on the candidates.
Okay, so this is again very interesting. We are taking the final conclusion from TEA, TEB, TEC, and we are counting how many student, how many samples are saying good, how many samples are saying bad, and the majority will be the winner. So stability will be there. Next, read.
It overcomes the problem of overfitting by aggregating or combining the results of different decisions.
Okay, so here word overfitting is new to you. Okay, so that we will discuss in some of the lecture, but in case of random forest there is no issue of overfitting. Next.
Random forest work well for large range of data items that the single distinctly does.
Okay, so we have seen in the forest we have picked very small samples that will not cover the whole region. So more sample means more accuracy, right, and more stability. Next.
Random forest has less variance than single distinctly.
Okay, so we are going for the voting, and majority will be the winner. So the variation will be less. Next.
Random forests are very flexible and possess very large high accuracy.
Right. So how many samples you have to draw? It is your decision. How to prepare decision tree? It is your decision. How many sample is to be drawn? It is your decision. What should be the quantity in each sample? It is your decision. So it is very flexible. Next.
Scaling of data does not require in random forest algorithm. It maintains the accuracy even after providing data without scaling.
Okay, so in boosting, what we have seen, for first sample, we were developing the model. Again, that model will be clubbed with second sample. But while combining, we need to give certain weightages. Whereas in case of random forest, there is no issue of weightages. First sample is decision. Second sample is decision. Third sample is decision. And the majority will be the winner. इथं आपण असं करतो का की फर्स्ट सॅम्पलचं जे कन्क्लुजन आहे त्याचं काहीतरी वेट, दुसऱ्या सॅम्पलचं काहीतरी वेट, असं करतो का? नो. सो दॅट इज नॉट द कन्सर्न इन दिस केस. नेक्स्ट.
Random forest algorithm implement good accuracy even a lot.
Proportion of the data is missing. See, interesting example we will take. Suppose if I ask this student how I am teaching to you, okay, definitely he will say if I ask directly, right? Okay. Now he will say something. Now if I ask to whole class how I am teaching, Now, who is telling better, single student or whole class? Whole class, of course. So this is the meaning of the this particular statement, because we are going with the majority. So majority will be always providing the greater accuracy. Next.
Complexity is the main disadvantage of the random forest algorithm.
Okay, so more number of samples, more number of decision tree. Of course, it is a complicated one. Next.
Construction of random forests are much more harder and time consuming than the decision trees.
Okay, so more samples, more decision tree. So it is a time consuming process, yes or no? So if you are dealing with the huge data set, let's say 2 GB data, and you decided to go with the 100 samples, so you can imagine how much big data you will be dealing with. So definitely it is a time consuming process. अनेकच डिसिजन ट्री ड्रॉ करायचं असेल तर व्हेरी इझी. नेक्स्ट.
More computational resources are required to implement random forest algorithm.
Okay, more data means more resources, right? Next. ओके, समजा खूप सारे डिसिजन ट्री आहेत, तुम्ही ज्यावेळी सगळ्या डिसिजन ट्रीकडे एकदम बघता, यू विल गेट कन्फ्युज, राईट? दॅट इज अ पॉसिबिलिटी. सो दिस इज वन अनदर इश्यू विथ दिस. नेक्स्ट.
Prediction process using random forest is very time consuming in comparison with other algorithms.
Okay, so this is statement related to comparing the decision tree with, let's say, support vector machine or navy based method. So when we compare different algorithms, so this particular statement is true for that. So for example, model 1 is developed by using decision tree, model 2 is developed by using navy base. So when you compare these two models, so comparatively navy base is simple as compared to decision tree. This is the meaning of this particular statement. Again, in this particular table, you will see the difference between random forest versus decision tree. Next, read first difference.
Decision trees normally suffers from the problem of overfitting if it's allowed to roaming of any control.
Okay, I will read now afterwards. Okay. Random forests are created from subsets of data, and the final output is based on average or majority ranking, and hence the problem of overfitting is taken care of. Second, a single decision tree is faster in computation, that we know. Computation is comparatively slower because more number of decision trees are there. When a data set with features is taken as input by a decision tree, it will formulate some set of rules to do prediction. Whereas in case of random forest randomly selects the observations. This is very interesting. Build tree, and the average result is taken. It does not use any set of formulas. So there is no hard and fast rule. For every sample, independently decision tree will be created. There is no common rule applied for all the decision trees. So that's it from my side. If you have any question, you can ask.